Hi everyone, my name is Sue. I'm a first-year PhD student in epidemiology, and I'm a teaching assistant for this class. So this video is created for you to better understand the paper Aflatoxin and liver cancer prior to our class. So this is pre-class overview, so we're going to review the paper in the class of February 20th. So let's see the title of the paper. So the full title of the paper is A Follow-up Study of Urinary Markers of Aflatoxin Exposure and Liver Cancer Risk in Shanghai, People's Republic of China. So the title is already saying a lot of information of this study. So our study population is a cohort of middle-aged men in Shanghai, China, who are recruited between January 1986, September 1989. And our outcome is liver cancer, and our exposure is aflatoxin. And how we measure this aflatoxin is that we're going to use the urinary samples, and then we're going to measure the biomarkers of aflatoxin. Study design is nested case control study. So our cases are liver cancer patients in this cohort, and controls are those without history of liver cancer, randomly selected from the same cohort. Because we sampled cases and controls from the existing same research cohort, this is why it's called nested case control study. Now moving on to our exposure aflatoxin. So aflatoxin is a type of mycotoxin, it's a fungal toxin, and it's mainly produced by two molds, but you don't have to know the mold's name. And the first mold is common and widely spread in nature, and is found when grains are grown under stressful conditions like drought. It's easily found in soil, decaying vegetation, hay and grains, etc., such as corn, oilseeds, nuts, and peanuts, and even some in milks, under the conditions are favorable to growth. The conditions are favorable to growth is high temperature and humid environment. So in this picture, when plant grows under the stress like drought and is stored under the pure conditions such as high temperature and humid, it grows from fungus. It's known that there are at least 13 types of aflatoxin, B1, B2, G1, G2, and aflatoxin B1 is the most predominant and the most toxic one. Let's go back to our study population, people in Shanghai, China. So some of you may know Shanghai is a city which is very humid and high temperature because it's next to the ocean, and the altitude is pretty low, which is almost the same altitude of San Diego in California. In Asian countries, staple food are grains, including rice and wheat. So as you can see in the picture, this is a rice that the fungus grows. This may contain aflatoxin. So then how to measure this aflatoxin? You may consume this aflatoxin accumulated food, but you really don't know. And you really don't know the level of contamination and how much the food contains aflatoxin from your dietary questionnaire, which is typically used for nutrition health research. This is why we have to use urine test. So what happens in the body when aflatoxin consumed? So as I told you, aflatoxin B1 is the most toxic one, and it goes to your liver. And in liver, there is a big family of enzyme, which is called cytochrome P450 enzyme. And there are several subtypes of enzymes under this big category. Let's go see the first line. This aflatoxin B1 is going to liver, and then by this enzyme, it's converted to aflatoxin B1 8-nite epoxide. And this converted form of aflatoxin is going to bind to the DNA in liver. So now this is called N7-guanyl aflatoxin B1. That's the first marker in the paper. And this can lead to liver cancer. There are other types of enzymes, aflatoxin M1, aflatoxin Q1, P1, G1. This is converted by different enzymes. So these markers, which is highlighted as green, can be detected from urine tests. Now I believe you can better understand this first table in the paper. Thank you for watching video and see you in class.